Hi, my name's John Monahan. I'm the principal investigator for the UAF Modern Blanket Toss program. It's a program where we're using UAVs to engage students from rural Alaska in learning more about STEM careers and motivating them to take higher level math, science, technology courses as they progress through high school, with the hopes that this group of students will go on to attend college and go into STEM careers. We're using a variety of UAVs, unmanned aerial vehicles, to progress the students through understanding of the how to use the UAVs and the science behind them. I'm making this video real quickly for the first time because where are your friends who have done this before as you're filling out the application for a program? So let me take you through the program just a little bit and give you a kind of a sneak preview of what we would discuss as we go into South by Southwest. So we started the program. We've learned a lot. One of the things I'd like to share is some of the stages that we've progressed through as we've identified the pitfalls of flying UAVs, breaking them, crashing, putting them back together, and also getting the supplies out, in our case, to 5 rural Alaska communities in Alaska where students don't have access to a lot of, hobby stores and things readily available to them. So we've progressed through how do you take care of this equipment, how do you involve students in fixing it. I would like to share those with you. I'm going to quickly turn this over. I have laid out some of the equipment that we do use, and we're pretty proud of just the way we started out. Is just a very simple understanding of UAVs by working with just connects. Easy to get a hold of, usually in the elementary classroom. It's easy to break. You can crash it. You can put it all back together rather quickly. And then using smaller props with double-sided tape, speed controllers, and then the receiver and transmitter, and a very small, simple battery. So by using this, we get into the very basic designs of what's involved in a quadcopter. Counter-rotating, balance, lift, all sorts of opportunities for math, science, and technology engagement at this level. So it's a safe, easy way to get students involved in flying, safety procedures, understanding the dynamics that are involved behind it. And as they get comfortable with this and they pass their flying license, and we're able to then move them on to our intermediate stage copters, which we are just using the DJI as a good stable platform that's capable of doing a lot. Most programs could even just stop at this stage with the features that are in here. But what we discovered is that these things crash. And without the knowledge that we had, here over in the prior, understanding speed controllers and all the various components in it, is that you're not able to fix these and get them back into the air. And that's for our students. That's a very interesting learning component. So the welding, the parts fabrication, everything that's involved in that. Is what's really exciting and engaging to the students. Ironically and interestingly, we found about half of the students really enjoy the flying process. The other half of the students enjoy the software, the program management, the 3D printing, some of the things that that we've also involved in here. So students get into that. What we've also done is had the students design some of the flying parts themselves, and we have a 3D printer going where they produce the parts and then they send it out to the communities that are also involved in the program. So we have one or two of these 3D printers out in the communities. They prepare the parts, and a lot of them we put in kits. We send it out to the sites that has all the materials in it, all the safety materials, procedure manuals, different things, and they can send those back. I'm going to show you a little sneak preview. Go to our fabrication lab over here. We had students this summer who came in and they produced, hi Scott, they produced a hexacopter. And so they were with us at the university for 6 weeks, and they produced from scratch hexacopters that they incorporated the 3D printing in, used carbon fiber boards to make a copter that can then lift a little heavier load, in this case a gimbal, a GoPro, that they can do some video and photography with, and then they were able to put it into 3D rendering programs. We had another group of students that were working with a GIS class, and they were able to take the pictures, put it into GIS, and do some change detection that was going on. So I'd like to talk about what we've learned in the past, also where we've gone with the program, some of the learnings that we've had, how I would see this incorporated into any classroom across the country, and some of the, this is a research project, some of the findings that we've been able to identify students have learned, and then leave it open for a question and answer period. Thank you very much. Look forward to seeing you in Austin.